every now and then, a new AI model drops that just blows up the internet. You know the type. The claims seem almost impossible. Well, the latest one to set everything on fire is called iQuest Coder. So the big question is this a genuine breakthrough, or is there something else going on behind the scenes?
Okay, so the team behind iQuest Coder dropped this chart, and honestly, these numbers are wow. They claim their 40 billion parameter model, which is pretty small, relatively speaking, absolutely wipes the floor with giants like Sonnet 4.5 and even the upcoming GPT 5.1 on some really tough coding benchmarks. And when you see a model this size claiming to do that, you gotta ask, can it really be this good? Or are we just looking at a whole lot of hype? That is the exact question we're going to dig into right here. We're going to try to separate the marketing from the messy reality.
So let's start with the hype, because there was a lot of it. This model came out of a Chinese quant hedge fund called Ubiquant, of all places. And the second it dropped, the internet just went nuts, with people immediately calling it the next GPT killer. The whole pitch, right? It's so simple and powerful. A smaller, open source model that anyone can run, and it beats the massive closed source models from the big tech companies. I mean, who doesn't love that story? But then, people actually got their hands on it, and that's where the story gets a whole lot more complicated. So what's supposedly the big secret here? What makes this model so special? Let's pop the hood and look at what they built, because it's not just another model. They came up with a genuinely new idea. It all starts with something they call the code flow paradigm. Okay, so instead of just feeding the AI snapshots of finished perfect code, they trained it on the entire process. The commit histories, the bug fixes, all the little changes. It's kind of like learning to write a novel by reading all the messy first drafts and the editor's angry comments, not just the final polished book. And that brings us to the core innovation, this thing called the loop architecture. Here's how it works. The model doesn't just read the code once. On the first pass, it kind of skims it to get the big picture. Then it loops back for a second, much deeper pass to really understand and refine the logic. You know, this quote from AI Code King just nails it. It's mimicking how we as human developers actually work. You do a quick read to get your bearings, then you go back and read it again, slowly, to really get what's going on. That's the whole idea behind the loop. And this whole loop thing also explains the model's really weird name, 40B, 80B. It's a 40 billion parameter model, for sure. But that two-pass system supposedly gives it the reasoning ability of an 80 billion parameter model. So you get that extra brain power without needing twice the expensive hardware to run it. Pretty clever, right? Okay, enough theory. The real question, the one that really matters, is how does this thing actually perform when the rubber meets the road? Well, testers put it through a whole series of really tough hands-on coding challenges to see if the reality lived up to those shiny benchmark scores. And this is where the story takes a wild turn. In one of the hardest tests imaginable, building a fully functional operating system inside a web browser, the model did something amazing. The first attempt with a simple prompt was a dud, but a more detailed prompts, it led to a result that was just shockingly good. I mean, the reaction from the tester, Bijan Bowen, says everything you need to know. The model didn't just build a simple OS. It created one with multiple apps and features. The quality was so high, it actually made him suspicious, like it was too good to be true. But, and this is a huge but, that amazing high point, it wasn't the whole story, not even close. The testing showed that this thing is a total mixed bag. For every stunning success, like a cool sand simulator or a slick-looking website, there was a spectacular failure. And this really gets to the core of the problem, this massive gap between expectation and reality. You ask it for a 3D racing game and it spits out, well, a really cool-looking 3D map that's completely broken. You ask for a 3D shooter in Python and it gives you a perfectly functional but totally 2D game. It just seemed to fall apart when faced with ambiguity. Oh, and there was another huge issue, speed. It turns out that clever loop architecture has a major downside. Testers said the model was painfully, frustratingly slow. Even on an absolute monster of a machine like an NVIDIA H200, it just chugs along. Trying to code with it is a real test of patience.
So what is going on here? How can a model be a genius on paper, but so hit or miss in practice? Well, the answer is a concept that's becoming more and more important in AI, and it's called benchmaxing.
Think of benchmaxing as the AI version of teaching to the test.
You can train a model over and over again on data that looks exactly like the benchmark problems. And yeah, it'll get an A+ on the test. But the moment you give it a real-world problem it's never seen before, it just doesn't know what to do. And this table just breaks it down perfectly. On one side, you've got benchmark problems. They're clean, they're isolated, they have one right answer. That's iQuest Coder's home turf. It's a genius at this stuff. On the other side, you have real-world coding, a total mess of old code, confusing APIs, and trying to guess what the user wants. And in that world, iQuest Coder just gets lost.
And if all that wasn't enough, here's the kicker. It turns out the main benchmark, the SWE bench, that gave it that incredible score was probably flawed. The setup accidentally included the entire Git history, which means the model could essentially peek at the answer sheet. That data leak pretty much invalidates its most spectacular result.
All right, so after digging through the hype, the tech, the good tests, and the bad tests, what's the final verdict on iQuest Coder? Let's tie it all together. So, is it a GPT killer? No, not even close. It just doesn't have that broad, common-sense understanding of the world that the big models do. But is it useless? Absolutely not. If you need a local tool to hammer out some complex algorithms or solve a logic puzzle, it's fantastic. And maybe most importantly, that loop architecture, that's a real genuine innovation we're probably going to see a lot more of. And that really leaves us with a much bigger question, doesn't it? The whole story of iQuest Coder kind of shines a spotlight on this growing tension in AI development. As we push forward, what do we want the goal to be? Are we just trying to build AIs that can ace standardized tests? Or are we trying to build tools that can actually help us solve messy, complicated, real-world problems?